web servers like Apache would look at the HTML, would find those kind of comments, and pull in the server-side calls. The thing that really changed everything from just being about publishing documents to being about interfacing with other systems was something called the Common Gateway Interface, or CGI. And CGI was a really simple idea. What it basically said was, if you write a program in whatever language you want, if it can read things in from your operating system environment and it can print stuff out, then you can hook it up to a web server, and when a request is made to that web server, your program will be run. It will be given a certain environment, it's to do its thing, and it's to send back whatever is to be sent back to the browser. And that's the way CGI worked, and it was the way that a lot of dynamic, interactive websites were built for many, many years. Even to this day, there are still sites out there that use CGI as a really simple way of getting a program to connect to a web server so that you can do stuff rather than just present documents. Another big innovation was, so when CGI started, you would write scripts, and the scripts would do something, and they would print out a bit of HTML, and they would do something, and they would print out a bit of HTML. So your code became this strange mix of, say, Perl code with little bits of HTML in between. And what things like PHP and ASP did was they flipped that around, they reversed it. So that what you would actually do is you would write HTML, and occasionally in your HTML, you would have a bit of code. In the case of PHP, it was a new language that was developed based on Perl. So it was written in C. In the case of ASP, it was Visual Basic. But that really started this whole move towards much more interactive sites that you could actually do things with rather than just read content. And so we started to see all these database-backed websites where there was a database containing information that was being accessed via the web interface. And most of these sites were built around a stack that was referred to as LAMP, L-A-M-P, because most of them ran on Linux, most of them ran Apache. For the database, most of them used MySQL, MySQL. And the majority of them used PHP or Perl, or some of them Python. It's lucky that those three languages all start with P, because it means you can use the term LAMP to refer to all three of them. But PHP was a predominant one. Perl was very big for this in the 90s. I think that's largely died away now. But that's all to do with doing processing on the server. Along came JavaScript, and the interesting thing about JavaScript was originally intended to be run on the server. It was developed by Netscape in the mid-90s. It was originally called a LiveScript, and it was supposed to be run in the Netscape web server. And then they got the idea, well, what if we actually put that into the browser as well? So the browser could do some computation, the browser could run some scripts. And because of the popularity of Java at the time, they decided it would be good if it was described as being like Java, so they changed the name to JavaScript. Much to the annoyance of a lot of people in the Java community, because the two don't really have anything to do with each other. So then you had a situation where browsers could do a certain amount of computation and calculation on the browser side, but the server could do stuff as well. And it led to the question, well, how do you then communicate between the two? Because no longer are you writing a document in HTML, a static document that just gets served up to the browser. Now you have stuff that can go on in the browser, you have stuff that can go on in the server, and the two might need to communicate with one another. Now, at the time, there was something else going on, which which became relevant to that question I just asked, but it was created for a very different purpose. And that was XML. XML came about mostly out of the publishing, the electronic publishing industry. They wanted a way of being able to write documents independent of whether those documents were going to go on the web or whether those documents were going to be printed. And so a group of us, and I was one of the people involved, set about working on a markup language that would let you describe things that could then be formatted for the web or formatted for print. And that's how XML got started. What happened though was the people that were interested in solving the earlier question that I mentioned of how do browsers and servers talk back to one another with data. Some people looked at XML and said, well, maybe XML can solve that problem. And so that's what led to what in the late 90s were referred to as web services. Microsoft, IBM, a bunch of other companies were very big into this. But what it was essentially trying to do is to use XML as a data exchange format, not as a document markup language, but for data exchange. And to use the web as a mechanism for that data exchange. Now, a key technology that came out around this time, it started off with Microsoft, but now is widely used by a lot of websites, a lot of different browsers, is Ajax. And that's become increasingly important. It was quite difficult to use in the early days, the late 90s and the early 2000s. But it's really become a predominant way of doing things now. When Ajax first came out, the X stood for XML. The idea of Ajax is the first A stands for asynchronous, because the idea was that you could have a web page that was loaded, and then once or parts of it were loaded, and then components on that web page would asynchronously interact with servers to get new information, to update things on the page, and so on. Over time, the use of XML for this got replaced by something called JSON. And JSON is now really the predominant way that data is interchanged on the web. XML still gets used in some places, but JSON has really replaced it as a way of getting data from the server to the browser, so the browser can use it. But this whole move towards things like Ajax and the use of JSON raises a lot of interesting questions about what a web page is and what a website is. Because we've moved a long way away now from there just being documents on a server that you access via a browser. There are now many websites that instead of you visiting lots of different pages, you essentially stay on one page, and as you perform different actions on the page, different parts of the page change. A great example of this would be something like Gmail, where when you're navigating around, you're not just going to different pages and retrieving a static document. What's happening is JavaScript is running in your browser, which is making requests not to entirely new pages, but asynchronous requests to retrieve bits of JSON that then come back to the browser and get styled and put in place. Before I get on to talking about specifics of Python, I want to give two examples of things that I've built or used that sort of demonstrate this move away from just serving up web pages. So hopefully I'll be able to I'm seeing something different on my screen than what was I'm sure it's meant to be. So the first thing I want to show you is this little tool I built earlier this year called Candelabra. And what it lets you do is basically set up various projects that you want to work on and time how long you're working on them. So maybe I'll say I'm going to set up a project called Keynote. I can basically turn on and off timers for different projects that I'm working on, and so record how much time I'm spending on my Keynote, how much time I'm spending on Java. Now, I point this out because this is, you may not have noticed this, but this is actually running in a browser. I've turned off the status bar and the address bar and so on. I could turn them back on just to prove to you that if I turn on back it is indeed a browser. I point this out. So the way that this works is it's entirely it's a single HTML page. It's all written in JavaScript. The information is actually consistent. So if I close down my browser and open it up again, the information will still be there. It's using something called local storage, which modern browsers support, as a way of basically letting you store information on the client side. Now, the only reason I mention this, there's nothing to do with Python, but it also has nothing to do with the web server, or perhaps what you would normally think of as the web, but it is an application that was built in the browser. And the initial code, the initial HTML and CSS and JavaScript, you do access via a URL, but the data is stored locally. And it sort of gives you a different idea of perhaps what the web application might be. Let me give you another example of that before we move on to Python and how Python will work together. Here is a web page that I run just to show what open source projects I'm working on at the moment, what their status is, what the last to be updated is. So you can see, it says how many public repositories I have in GitHub. It shows which ones have been updated recently. It's got a list of various projects. Now, again, what's interesting about this is a dynamic page, and if I go and change something in GitHub, it'll get changed here. But this is actually being served up as a static HTML page. JavaScript is being used to access an API that GitHub provides. GitHub has an API where if you access particular URLs, you can retrieve that information in JSON. And so I take that JSON and style it, and that's what's generated this page. Again, I just point this out to get you thinking about the way that the web has really changed and what the definition of a website or a web application is. It's greatly shifted. And while there's still a lot of the more traditional setting up of web pages going on, web development involves a whole lot more today than it used to. Let me see if I can go back to my slides. Okay. So now, let me actually talk about Python and the web and how these two great things come together. I mentioned before that the P in LAMP has always been possible to stand for Python, although in the early days it tended to mean Perl or even PHP. In the mid to late 90s, there was a huge Python project. It's probably one of the Python projects that people first heard about Python because of something called the Z Object Publishing Environment, or ZOP. And ZOP was a big project to provide a full stack for developing websites. It did all sorts of things like let you actually develop your website via a browser. You could actually set up your content via a web interface and so on. And so it had its own object database behind it, ZADB, and it gave rise to an extremely popular content management system called Clone, which is extensively used today. In a lot of regards, the whole ZOP and Clone approach has things have shifted a lot towards a much more modular rather than monolithic systems, where it's a lot easier to go in and see how individual components work and mix and match different components as well. And one of the key things that happened in the Python world to enable that was something called WSGI, or the Web Server Gateway Interface. Remember I mentioned before the very first way that computer programs could provide web pages was through something called CGI on the gateway interface. WSGI is really just a standard way of doing that specifically in Python. And to do that in a more efficient way, one of the problems with CGI is that every time somebody made a request to a particular URL, your script would have to be run. And then when it served up whatever page it was going to serve up, the script would stop. Somebody else accessed the page, the script would have to be run again. And particularly in something like Python, there's a delay as the interpreter runs up. You're basically restarting Python every time somebody hits a web page. And that's horribly inefficient. And various solutions were developed, fast CGI as a way of sort of keeping Python running even when a request wasn't being made, because it was ready when a request was made. But what WSGI did is really make it a lot more standard Pythonic way of building web applications. And now pretty much all of the web frameworks, some of which I'm going to talk about in a moment, now use WSGI. So, and then web servers like Apache, GUnicorn, and so on support WSGI, so that the web server doesn't need to know about a particular Python web framework we're using. And that's really done wonders for the ability for people to use Python on the web. So starting around 2003, 2004, we started really seeing the rise of web frameworks that were based around model view controller pattern and MVC pattern. And there are still many of these around, not just in Python, everything from Ruby on Rails, in the Ruby world, to structs in the Java world, and so on. There are many of these web frameworks in the last 10 years that adopt this model view controller framework. And in the context of web frameworks, what that basically means is you have some mapping to a database, a relational database typically. Although that certainly is changing. But traditionally MVC meant the relational database. Some sort of HTML templating language, similar to what we saw in the early days with PHP and ASP, where you had HTML with this code in it, although a much cleaner separation, so that the logic, as much of the business logic as possible, was kept out of the template, and the only logic that you had in your HTML template was displayed there. And then finally, request routing. When a request comes in, how do you map that URL to some bit of code that's going to call the database, pull data out, use an HTML template to render HTML to send out to the web. So a few different approaches in the Python world, different projects that took the MVC approach. The first version of Turbo Gears used something called SQL object as the object relation mapper, something called KID as a template language, and then Cherry Pie as the controller. Turbo Gears took the approach, unlike Django, which I'll talk more about in a moment. Turbo Gears took the approach of trying to take an existing third-party solution for each of these different areas. It took an existing object relational mapping tool, took an existing templating language, an existing routing, and integrated them together. The Turbo Gears 2 took the same approach, but it used a different choice for each of those slots in the MVC panel. So it used SQL Alchemy as an object relational mapping, Genshi as a templating language, and pylons as the way to do the request running. Although I haven't used it extensively, because I primarily use Django, SQL Alchemy is an amazing, probably the best example in Python of an object relational mapping, object relational mapping. So if you're doing anything involving, it doesn't even need to be web-based. If you're wanting to interact with relational databases and Python objects, and particularly if it's an existing database that you need to map back and forth with Python, I highly recommend taking a look at SQL Alchemy, even if you're not using it in the context of the web. But SQL Alchemy is what Tauber is within the Zope world, there's something being worked on called Repose BFG, and recently the Repose BFG folk and the Pylon people have combined forces to work on something called Pyramid. So Pyramid is another project in the Python world for doing websites. It's focused primarily not on the, you still need to add a object relational mapping, you need to add a template language, but for gluing all those together, Pyramid is another project that exists there. Another example of a project that tries not to do everything, but instead tries to combine existing components is Flask. Flask is unusual in that it's a web framework that started off as an April Fool's joke. I don't know how many of you are familiar with the concept of April Fools, but in the Western world there's this crazy tradition on the 1st of April. You make an announcement that's a complete lie and see how many people you can trick into thinking it's actually a real announcement. And all sorts of crazy things have been proposed. Google once proposed that they were going to build a base on the moon. And so they did a press release and a big announcement, but it was April 1st. But sometimes April Fool's announcements are actually real. Famously, Google announced Gmail on April 1st. And at the time, the existing mail services, this is just a little aside, it's going to be Flask, but you'll see why I mentioned this. But before Gmail came along, so there were free mail services like Yahoo had one. And they provided just a few megabytes of mail for free. On April 1st, Google announced that they were going to give people a gigabyte free mail. And it seemed so crazy, it was April 1st, everyone thought, ha, this is a funny joke that Google won. Then people started thinking, well, hang on a second. Maybe they could do that. Maybe that is something that's affordable, and guess what? When April 2nd came along, Gmail still existed, and it still exists today. So it was an example of an April Fool's joke that turned out not to be a joke. Flask is somewhere in the middle. It actually was supposed to be a joke when it came out. It was called, it wasn't called Flask, it was called Deny, I think it's called. But Armin Reinke, the creator of Flask, tried to come up with what he thought was the simplest possible web framework. That was kind of his joke. And it actually turned out people liked it. So he developed it a little further and it became Flask. Armin had earlier written his own templating language called Ginger. The later version of that, Ginger2, was what he used in Flask. Flask often gets described as a micro web framework rather than a full-blown web framework like Tauber or Django, because Flask is really just doing the core. It's providing the glue between a WSGI request coming in and you sending something back out. And you need to plug in something like SQL Alchemy if you want to talk to a relational database, or Ginger if you want to render a template, and so on. But that appeals to a lot of people. Certainly Flask gives you the most flexibility if you don't have a relational database, if you have some other kind of data source, or if you are wanting to do quite a different approach to rendering. But the framework that I'm most familiar with is Django, and unlike Tauber, which integrates a lot of existing things, or Flask, which tries to just provide a very small amount and add in what you need, Django tries to provide a lot more for you out of the box. It has its own template language, it has its own relational mapping, and there are advantages and disadvantages to doing everything certainly, if you want to get going quickly, Django's approach makes that possible. But if you want to do something that's particularly unusual, Django might get in your way a little more. But Django is certainly the most popular web framework at the moment. Many of you have probably heard of Instagram, a photo sharing site that was recently acquired by Facebook. Instagram is built on Django. Another big site with many millions of users. It's become popular in the last few months as Pinterest, another site built from Django. So Django, of course, by extension Python, are being used in very big serious websites. Django recently had a 1.4 release. Django had its first release in 2008. Well, it's 1.0 release, I shouldn't say its first release. Django was first released in 2005 and had an extremely long series of 0.9 releases. It had a 0.90 release and 0.91 release and 0.95 release and 0.96 release. Years went by between each of those. But 1.0 came out in 2009. 1.4 just came out earlier this year. Some of the new things that came out in Django 1.4 were much better support for time zones. For those of you familiar with SQL, the ability to do a select for update, so you can update rows in the same query as actually doing a query. Before this, you had to do a query to find out what data you wanted to modify, then modify it and save it, which is a bit more inefficient. A lot better password hashing, signed cookies, a lot of security things. A much more out-of-the-box experience with Whiskey, some project app templates, and better support for Windows testing. So I just want to finish up talking about a project that I've been working on for the last 4 years, something called Pinax, which is really a layer above Django. We'll talk a lot about this whole MVC approach, and whether you're comparing Turbo Gears to Django or Flask, they're largely sitting at the same level, solving those MVC type problems. What the Pinax project is trying to do is solve a different problem, a layer on top. Before we get into that, though, I want to talk a little bit about why we layer things in software to start with. One reason is the portability of higher layers. One of the things that Django does, for example, is it layers the database, the object relational mapping, is a layer on top of a series of database-specific backends. So when you're using Django, you don't necessarily care if you're using Postgres or MySQL, you're largely isolated from that. It means the code that you write that's going to run on a site that's running on Postgres, unless you're doing something Postgres-specific, needs to be moved to something that's using MySQL. So you're getting portability because you've layered the database access. But another reason for doing layering is the reusability of the lower layers. When you build a site, you don't want to have to reinvent the wheel every time. You don't want to have to build your own templating language and your own database, object relational mapping, and your own URL routing. So you often use a framework to do that, because chances are most sites that you build are going to have very similar requirements in terms of templating and object relational mapping and so on. So you can build that solution once, or someone else can build it for you, and you can reuse that again and again on different sites. And that's going to become really important for explaining what Pinax is. There is another reason. I mentioned the computer scientist Don Knuth earlier. Don Knuth is probably most famous for a series of books called The Art of Computer Programming that are sort of the books on computer algorithms. And they're quite difficult to understand, extremely rewarding if you can understand them, but they're quite difficult to understand. And Tim Peters, one of the main contributors to Python, who contributed a lot of stuff to both the core of Python and the Python standard library, in the introduction to the Python cookbook, he says, we read Keynote so you don't have to. What he means by that is, he's gone and looked at all the algorithms that Keynote has come up with and described in the art of computer programming, and then implemented them in Python, so you don't need to understand them, you can just use them. And it's another huge advantage of layering is that you can make use of things that have been developed by people that know a lot more about the subject than you do. One of the big things, not only these sort of algorithms that Tim Peters is talking about, but security is another big thing. If I had to worry about all the different ways that websites could be compromised, I would probably not get any web development done at all. But instead, communities like the Django community have people that are experts in web security, they understand which hashing algorithms are better than others for passwords, and why you really need to cryptographically sign your cookies and so on. They build that, they build it into Django, so Django has that out of the box, and I can get on with the job of building websites, which is what I really do. So at the end of the day, all this is about trying to get more quickly from an idea you have for a website to the realization of that idea. Seth Godin, an American businessman, has pointed out in the talk to a bunch of web developers that what you do for a living is not be creative, what you do is shit. What he means is the point of what you do as a web developer is actually create websites. If you're not actually delivering the website, you fail. So, Pinax is a project that I've been involved in for 4 years to try to make that a little easier. What it tries to do is build a lot of the common components on top of Django that you would otherwise find yourself building again and again. Things like user sign-up and management, components like comments or voting or rating, integration with things like Twitter and Facebook. All those sorts of things that a lot of websites use that aren't necessarily the core of the website that you're building, but if they didn't exist in something like Pinax, you would have to build them again and again. So Pinax provides some default templates, some reusable apps, some starter projects to get you going, and then this increasing collection of all sorts of different components that can be used in different websites. So just to finish up, one of the things that I want to point out is that the web now involves a lot more than even just the database in Python or whatever. And some of the stuff that I haven't really touched on that pretty much get used by most medium to large websites nowadays is some form of caching, some form of full text search, things like message queues, and Python and web frameworks in Python all have great ways of incorporating these into your website. Django has excellent integration with various caching products like Redis. There's something called Haystack, which does a tremendous job of providing full text search into Solver and other search engines. And another Python project, Celery, gives you a way of using message queues and so on when you've got long-running tasks that you want to run asynchronously outside of a request-response cycle. There's just a couple of other things I want to point out in this changing world of the web and what role Python might play that go outside of just this idea of serving up web pages. One thing that increasingly gets done is just providing web APIs. It's entirely possible that you could build with Python and a web framework like Flask or Django something that doesn't actually serve up web pages. It just provides an API that gets consumed by clients of other kinds. Or in some cases, build a website that also has an API. You saw before when I gave the example of the web page that shows the open source projects that I work on GitHub. That's an example where it's using an API provided by GitHub. GitHub isn't serving up any HTML, it's just serving up JSON. Now GitHub is using Ruby on Rails for that, but there's no reason why you can't use Python web framework to do exactly the same thing. And for example, one of the things my company has done is we've built some iOS apps for Python and iPad, where there's a server running, and it's running Django, and it's providing an API that iPhone and iPad are connecting to. So you don't necessarily think of that as it's not a website, but we're using a web framework, we're serving up an API via web technology. Another example of that uses Python is how many of you are familiar with Dropbox, which is a sort of file storage in the cloud. It's built with Python. So it's providing a service that you wouldn't necessarily think of as a website. And then there's the other side, consuming web APIs. Python has a number of libraries, both in the standard library and outside, for consuming web APIs. So you could pull in stuff via that. So just in closing, the main message I want to get across is that Python is a great language for the web because it's a great language in general, and that the web is becoming increasingly complex and there's so many different parts to it that Python can be an extremely important component in the overall web. Thank you very much.
Thank you. And we can have several questions for James. Yes, please.
Thank you for your very informative presentation. Recently, I heard about many times about the JavaScript HTML5. It seems that you haven't mentioned about it. Could you give some comment about that?
Sure. So, HTML5 is really just a term for all of the new stuff that browsers have been supporting over the last couple of years. There's a very interesting interaction that happens between the people that make the web browsers and the people that write the specifications of what HTML is and what CSS is and so on. And sometimes the standards bodies are ahead and sometimes the browser makers are ahead. What happened sort of historically, there was a tremendous amount of innovation in web browsers in the mid-90s, mid to late 90s, mostly between Microsoft and Netscape. And when it became clear that Internet Explorer beat Netscape, not much changed for a number of years. There wasn't really much innovation on the browser side. And then we started to see Firefox came out, and the WebKit project, which is behind both Safari and Chrome. And in the last few years, we've all of a sudden seen a lot more innovation. People really making browsers more and more advanced. That example I gave of Candelabra, the timer thing that I built, the fact that it can store data on the client side is a feature of these new browsers. And HTML5 is the term that's used for, so HTML changed, has sort of progressed, but JavaScript has gotten better, CSS has gotten better, there's these new browser features like local storage, and all of those together generally what gets referred to as HTML5. So it's a big innovation in the browser. And I certainly think all web developers should be trying to take advantage of HTML5, although it doesn't really change that much what you do with Python and a server side.
So can can Python play a role or somewhat about HTML5? Can Python play a role in such a scenario?
Absolutely, absolutely. Because most of the websites that my company builds use HTML5 technologies and use Python and Django to set them up. HTML5 doesn't really. HTML5 is just providing some new features that you can take advantage of in the browser. But the actual applications that you build, if you need something on the server side, you can still build all that with Python.
Hi, just Tony. Okay. My question, current jQuery is very popular. And how do you use jQuery to cooperate with Django to take advantage?
Yeah, so jQuery is what we use on all our websites as well. For those of you who may not be familiar with jQuery, one of the struggles that people had using JavaScript for a long time was not so much a problem with JavaScript, but the way in which you accessed and manipulated HTML from JavaScript. So if you're building a dynamic website where you're doing things on the client side written in JavaScript, you need to be able to add new bits of HTML and style different bits of HTML. And the API that was provided by most browsers was quite difficult to use. And so this thing called jQuery came along, and jQuery lets you access the HTML DOM using a syntax that looks a lot like CSS selector. And it's largely separate from what you choose to do on the server side. As long as, so what we do a lot is, and the sites we build is, we use jQuery to do stuff on the client side. Either jQuery makes it really easy to pull stuff using Ajax, so it could pull JSON that then gets styled on the client side, or it could pull fragments of HTML. Whether it's JSON or HTML coming from the server, we're using Django to produce that. So Django is pulling stuff from the database, it's constructing either JSON or HTML fragments, it's sending it back to some code that's using jQuery to then manipulate the web page. So the two work very well together.
Thank you.
Yeah.
Hi, what would be the best approach to integrate SSL layer and the subdomain with Django?
So there's depends exactly what you need to do, what you're wanting to do with subdomains, but for the SSL question, there is, well, to a certain extent, you can just use SSL without Django even necessarily knowing that you're using it. You can just, on your front-end web server, provide SSL. But there's a great Django app called Django Secure, and it adds some nice things like, one of the things you want to do when you're using SSL is you want to make sure that if somebody accesses your website at HTTP, you want it to redirect to HTTPS. You want to make sure that cookies are only sent via HTTPS. You want to make sure that there's all sorts of little things that you want to do. If you're using SSL, you want to use it properly. And so this app, Django Secure, lets you very easily add that capability to your Django site. For subdomain stuff, I presume you mean that you want to get a different, you want to have a single Django site, but depending on what subdomain the person visits, they get different content?
Yes, exactly.
Yeah. So there's a number of ways you can, a number of different solutions. There's an app called, I think it's called Django Sites, which what it basically does is it takes the subdomain that you're wanting to access and makes that available in all your views. So any queries you want to do, you have that bit of information available. So you can filter your queries differently or show a render a different template, whatever, depending on what's up there. So, yeah, Django sites and Django security.
How about multiple domain with one Django application?
Well, that's what that would give. On multiple domains completely, I think that will solve the same problem. Yeah, because from Django's point of view, all it cares about was what was the full host name. So if they have the same IP address, whatever, if they're going to the same Django instance, then as long as your views know what the site name or the host name was, you can act differently.
And there's another question, right?
I'm around for the rest of the day, so you can always come and grab me.
We can only allow one more question, or you have several questions. Yes.
Excuse me, I want to have that question about in traditional web, does client have a request to the server and the server response data to the client? And after the Node.js and WebSocket appears, server can send data to the client without the client sending request. But can Django do anything like this?
I certainly, out of the box, it doesn't. I suspect there are probably some apps that support WebSockets, but I haven't used any myself. I've not done much with WebSockets, although they certainly do serve a particular use. I've never had to build a site that's really needed WebSockets as opposed to polling on the client side. So, unfortunately, I don't know off the top of my head of a particular solution, but the challenge is that Django is normally not executing code unless you're making a request. So the only way you would get that you would be able to execute code on the server side that is making the WebSocket request is if you had something like Celery or something that was executing regularly. Because it's based on, well, actually I should correct myself there. It depends what's triggering the event that's going to send to the WebSocket. If it's something another user has done, then it's quite easy for Django to do. So in other words, if you go to your web browser and you send me a message, and I'm supposed to get a notification via WebSocket, that's fairly easy to do in Django because I can do it in the same code that's handling, Django code got called when you sent the message. If it's something else going on, like I want to send a WebSocket when an alarm goes off or a certain time is reached, then you need something additional to Django, like Celery or something that's running all the time, even if there's no request going on. But it's certainly possible, but you would need something in addition to Django in order to support sending messages if there's nothing going on the website to trigger it.
Yeah, I think we have to stop here, and I believe you have